Hi everyone, and welcome to my talk about hands-free coding with gaze detection in JavaScript. This project is something that I'm exploring on my free time. It's not intended for production, so my motivation is not for it to be widely adopted. I'm mostly interested in experimenting with different ways to write code and think about what it would look like to write code without using the keyboard. So we're probably going to have to use our imagination a little bit for this talk, but hopefully you'll learn something and it will give you some ideas of what you can do with JavaScript. My name is Gerard. I'm currently working as a senior front-end developer at Netlify. I'm also a Google developer expert in web technologies. I wrote a book last year about Tensorflow Js for JavaScript developers. And I love to make random things with JS, and the project I'm going to talk about in this talk is my most recent one. So the inspiration for this talk and project comes from the experiment Look to Speak by Sarah Ezekiel and Google Creative Labs. It's an Android app which enables people to use their eyes to select pre-written phrases and have them spoken aloud. So it's intended for people with restricted mobility to be able to communicate more easily with other people. So by looking left and right, you select phrases you'd like to be spoken aloud. Looking a bit more closely at the UI, we can see that the app has a phrase book in which you can write phrases you're most likely to use. Then the UI is split in two columns, and it uses the direction of the user's gaze, so using the device's camera, to filter down the list until there's only one option available to speak. I thought that this way of setting up the interaction was really interesting. I've worked before on interfaces to help people communicate with eye direction, and also using a brain sensor, but I was doing it kind of wrong or in a very inefficient way because I was reproducing the keyboard we're used to using with our fingers, but to be used with other body parts like your brain or your eyes, which isn't really the correct way to think about solving this kind of problem. One example of this is a project I built about 4 years ago to select letters on a keyboard by tilting my head in different directions. So I quickly trained a machine learning algorithm to recognize the direction of my head using the webcam feed. You can imagine that the amount of words and phrases I'd be able to type in a minute would be much longer than if I was splitting the keyboard in two and filtering down the list each time I tilt my head. For example, if I wanted to use the letter M, that's at the end of the keyboard in this example, I'd have to wait until it goes through 26 letters. However, if we were splitting this layout in two columns of 13 letters each, I'd only have to tilt my head, 4 or 5 times, which would allow me to write words much faster. So after coming across the Android app Look to Speak that I talked about just before, I tried it, I had to, and got really impressed with how accurately you could track gaze direction. So obviously, I thought I have to try to recreate this in JavaScript. Look to Speak is an Android app, but I love to see how far I can push things that can be built with web technologies, and I spent some time doing just that. And here's the initial result. I used a machine learning model with Tensorflow Js to do the gaze detection and implemented some kind of keyboard interface to write words with my eyes. This experiment is live if you wanna check it out. It works on your laptop and on your phone, which is also quite impressive that this kind of stuff can also work on your phone now. But I think that at the same time, or around the same time, I heard of a project by Josh Como to implement hands-free coding, but with voice detection. If you're interested, I'd recommend reading his blog post. He's also using eye tracking as a mouse replacement, but he's using an external device plugged into his computer. And I thought, wait a minute, I want to try and see if I can use the built-in webcam in your laptop. I love to work with the constraint of doing with what I have, which at the time of exploring this space wasn't very much. I basically just had my laptop. And thinking about his project, I thought about a few pain points of his solution. So having to buy an additional camera hardware for eye tracking is not really something that I wanted to do, but also with voice detection, you don't really have much privacy in some environments. You couldn't really code in a cafe or a library. You know, if there were a few developers in the cafe, that could become quite messy if everybody was speaking to their computers to write code. So I went the route of trying gaze detection. But to achieve this, I started thinking first about how we write programs. And what I mean by that is that I spent some time thinking about like the semantics and syntax of programming. There's only a certain amount of words or like reserved words that you can use in different programming languages. And there's also a specific amount of commands that you can try to execute. And this could become our phrase book. The first thing that you might have written in code was a variable, and your code base is probably full of them. But you also have functions. You have import and export statements if you're writing modules. You have logs to see what's going on in your app, you know, when you're debugging. You have return statements. You have logical operators, logical statements, web APIs. So that's not a full list of the type of things that you can do in JavaScript or in programming in general. But I'm using this as an example to remember that you can't write just anything you want. There's a certain structure. And even after defining these elements that you can define, if you go a level deeper, there's also specific constraints. So for variables, you declare them with var, const, or let. Again, we're staying in JavaScript land. For functions, you have function declaration, function call. You can write your functions as arrow functions, anonymous functions, immediately invoked function expressions. For import and export statements, they can be default or non-default. For logs, you're probably very familiar with console log. I definitely am, but there's also console.table, console.group, even more that I've actually never used, but there's only a specific amount. For return, we got return. For logical operators, we have and, or, more than, less than. For logical statements, we have our loops or if, else. And even in our web APIs, we have a specific amount of ones that you might have used before, like fetch or get user media. So now that we reflect a little bit on the syntax of how we write our programs and what is possible in JavaScript, we can conclude that we could create some kind of phrasebook of commonly used coding patterns. But what about the gaze detection part of the project then? So I'm using three main tools. Tensorflow Js for the gaze detection in JavaScript, Electron to make a little desktop app for my interface, and Robot.js to emulate the keyboard inputs sent from my Electron app to another app where I'm writing my code. To dive a little deeper into how this is built, let's look at a few code samples. So for the gaze detection, I start by importing the face landmarks detection machine learning model, as well as a couple of other TensorFlow JS packages. Then I have a function that loads the model. Don't worry about reading and understanding all of this if you've never written TensorFlow JS before. It's more about I care more about you understanding the logic of how I built this, and I'm sure that then you could figure out the actual syntax. And then I have a function to set up the camera feed using the get user media API, but I'm not going to dive too much into details in that particular function because this part of the code is not directly related to machine learning. It's more of a standard web API you might have used already. Then in another function, once the model is loaded, I call the estimate faces method, and I pass a few different parameters, including the video feed and the predict irises as true, because that's what I'm going to use for the gaze detection. Once I get prediction detected in the video feed, and that usually is triggered once it sees that there's a face in front of the screen, I loop through the predictions and I access the data points I'm interested in. So the predictions come back as an object with different properties, like where the mouth is located, the nose, etc. And here I access the X and Y coordinate of my left iris relative to the width of the video feed. So you could use the right iris as well. There's no particular reason why I use the left one. I guess my thinking is left to right, so I started with left. Then I also calculate the X and Y coordinates of the bounding box of my face on the screen. So if you're not familiar with this term, the bounding box is like the rectangle that would surround your face on the screen. So to be able to calculate the direction of my gaze, I need to know the position of my iris in relation to the borders of my face. If the space here gets bigger, then I'm more than likely looking right, and if it gets smaller, then I'm more than likely looking left. Then I detect that, if my full face is on the screen, so I don't trigger this code if there's only half my face in front of the camera. Then I do some calculation to try to get a normalized value for the x coordinate of my left iris so that I can come closer or further away to the camera and it would still work. So you can imagine that if I didn't normalize that value, if I go closer to the camera, the distance between my left iris and the left side of the bounding box of my face would get bigger because I'm moving in a 3D space. So when I move, in my real face, it doesn't actually change. But as we're working in a 2D space on the screen, it would look like the space between the bounding box of my face and my left iris would grow. And that would make our prediction less accurate. So then this is why I'm normalizing the value. So by doing that, I get a value between 0 and 1, no matter the distance of my face to the webcam. So this way, I can decide through trial and error that when the normalized value of the distance between my left iris and the left side of my face is more than 0.355, I'm looking right, and when it's less, I'm looking left. So all of this code to detect the gaze direction is actually isolated in a separate NPM package that I called gaze detection, so I could reuse it for multiple projects. And for this particular hands-free coding project, then I import my own package. I call my load model method to be able to use the machine learning model. I set up the camera feed, and I pass it in my setup camera method. And I start calling the get gaze prediction method that returns the gaze direction right or left that I described before. Then if the direction is right, and if it's different from the previous detection detected, because you get a prediction multiple times per minute, and I don't want that to trigger my code multiple times if it's not the act intended by the user. So I usually reset the previous direction detected versus the current one. And here I'm not going to go into too much details, but I'm slicing my array of options to only select the half selected by the user, and then I update the UI, and same for the left direction. So I keep doing this until there's only one option left displayed on the screen, which should be the one that I want, that I end up selecting with my eyes. So what happens then? To keep it short, I use the Electrons IPC renderer module that is used to communicate asynchronously from a renderer process to the main process to send the command that I want. And in that main process, I use the robot.js package to emulate a keyboard input. So you can type strings with a certain letter, or you can have key tabs like tab or space. And the final result is this. So you can see VS Code that starts with an empty JS file on the left, and a browser preview in the middle, and my little Electron app UI on the right. As I filter down options by looking left or right, some code snippets are written in my code, and then we can see the browser refresh and show me my React component. It's a very small component. It only renders a string, so there's not much logic to it, but it was only to demo how it works. So this is where you can imagine that if I had built this the way that I've built previous experiments, where I'd really have to write each word letter by letter, it would take me much longer than the 30 seconds it took me to write that component. As I knew I wanted to create a React component, I actually looked into a VS Code extension that has React snippets that you might already be using, because the concept is the same. Shortcuts like writing the letters R, C, E, and then pressing tab will create for you a skeleton of a React component. So this is kind of what I used in my UI. So it's kind of the same thing, but I use my eyes instead of using the keyboard. And then it made me remember something you might have seen in the past few months. So I'm talking about Github Co-Pilot. If you're not aware of what this project is, it's a tool that uses machine learning, and that has been trained on tons of lines of code from public GitHub repositories to kind of write code for you. So as you start typing in VS Code, it will give you suggestions of what the rest of your block of code could be. So even a tool like this could make hands-free coding easier. I know that people on Twitter seem to freak out a little bit about a tool like this, like it's going to take over our jobs. But again, this is where you can see that the interesting thing in programming is the thinking part of it. Technically, having to type is the last thing that you want to do. Even if you're only prototyping, the thinking always comes first, or at least it should. But seeing a tool like this made me reflect again on the fact that a lot of the code that we write is the same. When we think about it in independent blocks of code. How many times have you implemented a form or a button component? And what differs is in the systems that we build, how these pieces of code are organized together to build a product, and that's more the thinking part of programming. A personal experience I've had with Co-Pilot is when I was writing a blog post for the Netlify blog. I was writing it using Markdown directly in the codebase in VS Code, and I forgot that I had installed Co-Pilot a few days ago. So I was writing my blog post about machine learning on the Jamstack, and I started seeing a suggestion after my cursor. So I was like, what's that? I started reading it, and I had this reaction of like, whoa, I was actually about to write just that. It was a very weird moment because, you know, it was between thinking like, oh no, I'm so predictable. I'm just saying the same thing as everybody else. Like, I'm not special. But also like, whoa, I can write posts so much faster now. Because what matters is my train of thought and how I decide to link my ideas together, not necessarily that the words I used in independent phrases are the same. So I'm kind of hopeful that maybe a tool like Github Co-Pilot could allow us to develop more hands-free coding experiences. But let's see what happens in the future, because I know that I might feel a little weird about Co-Pilot having been trained on public repositories without people actually knowing. And that's an ethical question, but we could think about this same process, but trained internally on your company code base, for example. So I've talked a lot about, you know, the concepts and the UI and the tools that I used and, you know, the code and what it could do in the end. But there are limits. There's always limits. And I think it's interesting and important to consider them. So from what I understand, we can't access the camera in a VS Code extension. So I had to build an external Electron app. But maybe that's not so bad. I mean, to me, it started as a limit because I would have loved to integrate this directly in VS Code. But in the end, it's like this kind of time where a limit actually might be a good thing, because now it means that I can work with multiple editors and not only VS Code. And as it's all in JavaScript, it could mean that I could also build a browser extension to have hands-free coding that would type on a code sandbox page or CodePen. But you know, if you want something that only works on VS Code, you can't currently access the camera in an extension. Another limit is that the UI requires initial setup with correct code snippets. In my example, I knew that I wanted to create a React component. So I used React snippets, but you'd have to adapt it to the language and framework that you'd like to use. You know, if you're coding in Python, you know, the way that you declare your variables is different. So you wouldn't need the JavaScript things. So, you know, I don't see it as like a huge limit, but it's something to keep in mind. Another limit is that there is a learning curve when learning a new tool and layout. You probably don't remember the first time you used a keyboard, but you are probably much slower than you are now because you didn't know yet the placements of the letters on the layout, whereas now you can probably code without even looking at the keys. So it can take some time to get used to it. And I know that as we want to, you know, program really fast, sometimes when we think about new experiences of using a UI for hands-free coding, we might be thinking, I would never use that because I can type faster with my fingers. And well, maybe that's just not for you then, but also it always takes a bit of time to get used to a new way of doing things. And then finally, computer vision needs proper light setting. If you wanted to use something like this, it would probably work better if you have enough light shining on your face. By night, if you want to code in the dark, the iris detection wouldn't probably be as accurate. But also there's a known problem in machine learning and facial recognition that models are not always good at recognizing faces of like non-white people. I'd hope that companies are working on diversifying the data that they feed their models with, so we fix this problem. But for example, I don't know the data that the Tensorflow Js model I used was trained with. But then this is also where a project like this could be adapted to using something else than the webcam. And what I'm thinking of is to use directly your brain or your brain data. So in one of my projects earlier this year, I worked on detecting intentional blinking using a brain sensor. So I noticed that there's a spike in raw brain live data when doing an intentional blink that can be used to train a custom machine learning model and then build this kind of interaction where it wouldn't matter if I'm coding during the day or night, or it doesn't matter if a model wasn't trained with people of color, because then we could use direct input from your brain. My very first rough prototype was only detecting one blink, but the next step would be to train my model so I can recognize looking left or looking right, or blinking left, blinking right, to use that as inputs as well, and then maybe match that with my hands-free coding UI. But that's for another day. In the meantime, that was it for today. Hopefully you're a bit excited about how far things have come, and the fact that now we can do machine learning in JavaScript. And maybe you want to give it a try. Maybe, this talk gave you some ideas of certain UIs that you would like to try, or maybe you have some ideas about how to make hands-free coding experiences better. But anyway, if you have any question, or if you want to check any other side projects that I'm building, I usually share what I make on Twitter at devdevcharlie. But otherwise, thank you so much.
All right, and thank you, Charlie. So we've got some good Q&A over on your AMA channel on the Discord, and I want to just remind our audience to drop in over there for Q&A with you and a bunch of speakers from yesterday and today, so that they can see what other people have been asking, what the answers are. But today, right now, we got a couple. So the first one is, how can people get started with machine learning in JavaScript?
So I think when I talk to people, often they kind of feel like there's a barrier to entry because TensorFlow JS has like these fancy words like what's a tensor and things like that. But what I would love people to know is that there are ways to start that are a bit easier with like pre-trained models, where it's a package that you import in your app, and you don't have to create your own neural networks and things like that. So I started with TensorFlow Js, but there are other libraries out there. And yeah, what I would want people to know is that when I started by importing a pre-trained model. So you can have object detection or like speech recognition or even text classification. And you don't have to do any training yourself. You import a package and then, you give it an input like a piece of text, and it does the whole detection itself. So to me, the way to get started is to find an idea that gets you excited, so that you're not that scared of like getting into this space, and even replicating a project. I think I started with the Hello World of machine learning, which is I think it's working with the MNIST data, like the whole bunch of data to recognize characters in a picture. And I followed a blog post, and I was like, okay, that looks like it's all right. And then I went from there, and I experimented with more models, and I kind of dived into it. But I know that it can look scary. I think it was on my list of things I wanted to learn for a while, and I didn't actually explore it because I was a bit scared as well. But once you get started and you realize how much you can do, it's definitely a good space. And don't feel like you have to write your own model from scratch at first. Yeah, that I would have definitely stopped looking at it if it was the first thing that I wanted to do. But yeah, to me, like the documentation of TensorFlow JS is okay. I think that it could be more beginner friendly, but starting by following tutorials and then going from there is usually my way of going. Yeah.
Okay, we got about 20 seconds left. So
okay.
20 seconds, what are some other JavaScript tools for machine learning?
So there's ML5.js that is built on top of TensorFlow JS that I think tries to have that more beginner-friendly atmosphere and community around it. So if you are interested in machine learning, maybe don't start straight away with TensorFlow JS and try ML5.js instead. That was 20 seconds.
All right. Thank you so much, because actually we are going to now hand the stage over to Lizzie Siegel, who's going to talk about detecting masks with that library you just mentioned.
Awesome.
So thanks again, Charlie, and over to you, Lizzie.